All right, chemistry kids, here we go. We're going over our discussion notes. We broke the density part. You should have watched part 1. Now this is part 2, the second part of density that we talked about. And it's really about looking at a graph and what you can get from it. So here we have a graph of 2 different metals. It's got a title. It's got a y-axis with labeled grams. It's got a x-axis that's labeled cubic centimeters, so I know it's a volume. And then we have 2 different lines, one for each metal. All right. So now the slope of this graph, which is rise over run, slope is rise over run, is mass over volume. Mass over volume is equal to density. So you're actually graphing the density of these different metals. How do you find different points on here? And that's kind of what we're going to go over, and how to figure out mass and density and volume if you need to. That's what we're doing. So if I look at this stuff and I see for the first question here, from the graph, the mass of 8 cubic centimeters of metal A. So I'm going to use this line, and I want to find 8 cubic centimeters. So look at my intervals down here, and I say, oh, the intervals go up by 1. So 8 should be here. I'm sorry. These go up by 1, so 8 cubic centimeters should be here. There's 8. So what I do is I draw this line up to where 8 is, and it's not the straightest line, but it'll work. There. Then I bring it over here, and I say, what is my mass? And my mass is somewhere estimated about 45-ish. Somewhere in there. I'd take 46, maybe even 44. And it's going to be, grams. All right. So that's how you look at the graph. And then the second one is for metal B. So I'm going to look at this line, which is metal B. And I say 70 grams. So I find 70 grams. I look at my intervals here and say, well, the intervals go up by tens. So here's 50, 60, here's 70. I run it over to my line. I run it down to the volume. And again, not the straightest lines, but it'll work. And I say, okay, it should be somewhere around here. And it's not quite 9, but it's over halfway to 9. So you'd probably say like 8.8, 8.7-ish, somewhere in there. That would be a good measurement. Okay, and mark your graph on how you did that. Well, we marked the graphs right there, so that's how we looked it up. All right, so it's where the points intersect and where they kind of collide. That's where you're going to figure this out. This question right here says, use the density of B to determine the answer to 2B. So basically, how can we find this in a different way? Instead of just looking at the graph, can we do some calculations to figure it out? Well, first of all, we need to figure out our density. So our density of metal B is, remember, it's mass over volume, 70 grams over 8.7 cubic centimeters. I wrote that in there. Grab your calculator, 70 grams divided by 8.7, and we should get an answer of 8.0459, blah, 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 keeps going. But this isn't our real answer, so you gotta think the 70 has a decimal, so it's to be 2 decimals and 2 decimals, so we round this to 2 decimals, so actually the best sig fig answer would be 8.0 grams per cubic centimeter. So if you don't know about sig figs and how they use calculations, make sure you watch the sig fig video to give you a little refresher on that, because we did talk about it in class a bunch of times. So that's how you work with a graph. So it's just another way to find density. So now that we have density here, now we should know that, what are we trying to find? We're trying to find volume here. So we know volume is equal to mass over density. So we have 70 grams, which is what we have from here. 70 grams over, and then our density, which we just figured out, 8.0, and that should equal our volume, and we should get a number close to this, if we're good. Let's check it out. 70 divided by 8, enter, 8.75. We got 8.7, so our measurements were pretty right on. And if we round this, two sig figs, it's going to go to 8.8 cubic centimeters. All right, so be able to find the mass, volume, density, not just by looking at the graph, but also doing calculations. And that's what this next part is. It's all about revisiting the calculations. All right, it has nothing to do with the graph, it just has everything to do with actually calculating density. So the first question is, what is the mass of 225 cubic centimeters of ethanol? So we're trying to find mass. Mass is equal to volume times density. So plug in your numbers. Well, for volume, I have 225 cubic centimeters times it by 0.789 grams per cubic centimeter, and I should get an answer. Let's punch it in our calculator, see what we get. 225 divided by 0.789. You should get an answer like that. All right, that's not the right answer because we got to conclude sig figs. We have 2 sig figs in 225. We have 2 sig figs in 0.789. So that means we have 3 in each. Sorry, 3 and 3. So that means we have 3 in our answer. So 285 would be our answer. And because cubic centimeters cancels out, it should be grams. There's our answer. The next one's asking you to find volume. So we know volume is equal to mass over density. Plug your numbers in. Well, we have mass, 75.0 grams, 3 sig figs, over 0.789 grams per cubic centimeter. Punch in your calculator, figure out the answer. 75 divided by 0.789. And you should get an answer of 95.05, and that's the correct sig figs, because you want three significant figures, 95.1, and because grams cancels out, it should be cubic centimeters. All right, so there's a recap of calculations you should have done. Let's talk about what it actually means. The density of water, which is pretty well known, you might not know it right now, but you will, is actually 1 grams per milliliter. And this question here, what does it mean? Well, so in other words, what does grams per milliliter means? It means that I have 1 gram per 1 milliliter. All right, just like if this was, say, 15, it'd be 15 grams per 1 milliliter. So make sure you know what that is actually, that label is actually telling you when you have multiple labels in there. All right, so there's part 2 of the density. Coming up, we're going to have a scientific notation review. All right, we'll talk to you later.